When you're finding the limit to infinity and you get a number, that's actually the exact same thing as a horizontal asymptote. And if you remember from last year, there's actually shortcuts we can use to find those values algebraically. All right, so you have, it's easiest if it's seen in a fraction form, like a rational function. And then if the degree of the numerator is bigger, then the limit to infinity or negative infinity is going to be either a positive or negative infinity. And if you remember what I said for AP Calc exam, either one, positive or negative infinity, you can just say d and e. So you don't have to worry about which one it is, positive or negative. You can just say d and e. Okay? That's if the degree of the numerator is bigger. So if you have x squared plus 7 over x minus 3, right, 2 is bigger than 1. So we'd say the limit to infinity is infinity, or you can just say d and e. I believe delta math just says d and e. Okay? If the degree in the denominator is bigger, then the limit is 0. Because think about it. If you take some number and divide by a huge number, right? That's what's happening. The denominator is going to infinity. That's basically 0. So if the denominator is bigger, the limit to infinity or negative infinity will be 0. And if the degrees are the same, the limit's going to be the ratio of the leading coefficients. So in this case, you have x, let me get a little highlighter here. You've got x squared and x squared are your biggest degree terms. They're the same, so the limit is 2/3. Okay? And it's that simple. So let's take a look at some examples. I put this key up here just to remind you. Okay, so we've got limit to infinity. So we want to identify the biggest degree in the numerator and the denominator. So in the numerator, we've got x squared. In the denominator, we have x to the third. Since the denominator, x squared, is bigger than the numerator, the limit is 0. You don't have to show any work. That's it. Same thing with the next one. We want to identify the biggest degree on top, which would be 56x to the fourth. And the biggest degree on the bottom, which is 30x to the fourth. Since the biggest degree is the same, the limit is just the ratio of the leading coefficient. So 56 over 30, which you can leave like that, or if it says simplest form, just reduce the fraction. Okay, next. All right, so this one's in like factored form, but again, all we care about is the biggest degree term. So if you're like, think about it for a second, you can totally shortcut this and just say, well, I'm gonna get the biggest degree when I multiply x cubed by x cubed, right? So that's gonna give me a negative 8x to the 6th because you add exponents. The next term is only gonna be x to the third, so that's irrelevant, it's not the biggest one. In the denominator, the biggest degree I'm gonna get is when I multiply 9x times 2x. So that's 18x. Again, if that's too confusing for you, feel free to multiply the whole thing out, but you don't have to. You just need the biggest degree term. Since the numerator is bigger, that means a limit does not exist. Oh, I left off my limit thing here. It's all right. The limit as x goes to infinity. It's equivalent to that. So that's d and e. The limit does not exist. Lastly, same idea. We want to multiply. We want to find what's going to give us the biggest degree term. So negative x and x cubed will give us the biggest degree terms. This is the same thing as saying the limit as x approaches infinity of negative x, so that's negative x to the fourth. And the denominator, the biggest degree would be this one, which is negative x cubed. Since the degree on the top is bigger, that would say the limit does not exist. Okay? So again, you don't need to show a crazy amount of work. You just need to be able to identify the biggest degree at top and bottom and see which one's bigger. When it comes to radicals, it gets a tiny bit more confusing because you have to think about order up here. Okay, basically the biggest degree term here, right, would be the square root of x squared, and down here would be 2x. So if we simplify that, that's the limit. It's equivalent to the limit as x goes to infinity. The square root of x squared is just x over 2x, so then the degrees are the same, so the limit is just 1/2, because there's an divisible 1 over 2. Okay, this is where it gets a tiny bit tricky. This is the exact same problem, only this is to negative infinity. And why that matters is because technically in the one we just did, you're squaring it first and then taking the square root. You're squaring x first and then taking the square root. So no matter what x is, when you square it, it becomes positive. So really you end up with the absolute value of x once you take that square root, because it will always be positive, because again, you're squaring it first. So same idea here. This is the same thing as saying the limit as x goes to negative infinity of the absolute value of x over 2x, because again, you are squaring. So when you plug in negative infinity, the numerator is going to be positive because it's always positive, but the denominator is going to be a negative because you're plugging in a negative infinity. So you actually end up with a negative 1/2. And that's a really rare case. So if that's over your head, don't worry about it for now. We'll have time to look at that again. But just something to keep in mind with square roots. If you've got another root, like a cube root, for example. So again, biggest degree term here would be negative 8x to the 9th, and biggest degree here would be 2x to the 3rd, okay? So if we simplify the square root, and cube roots keeps the sign, whatever it is, right? So the cube root of negative 8x to the 9th, the cube root of negative 8 is negative 2, and of x to the 9th would be x to the 3rd, right? You divide by that coefficient. I don't mean coefficient, by that index. Okay, and the denominator would be 2x to the 3rd. So they're actually the same degree, so the ratio would be negative 2 over 2 or negative 1. And I keep messing up my notation here. It doesn't actually equal this. It equals the limit as x approaches infinity of this. All right, and lastly, biggest degree term here is also negative 8x to the 8th, and here would be 4x to the 3rd. Wait, those are the biggest ones. So the numerator would be negative 2. Now that doesn't go in evenly, so I would just write 8 to the x to the 8 over 3. Right, 8 over 3. The denominator is 4x to the 3rd. So 8/3 is smaller than 3, right? Because 9/3 would be 3. So 8/3 is smaller. So the denominator is bigger. So the limit as x goes to infinity would be 0 because the denominator is bigger. All right. Those are probably the most tricky situations. The rest are really simple. And lastly, so if you have x to the 4th and x to the 3rd, it's easy to see which one's bigger or smaller. Just to keep in mind when it comes to functions. So the least magnitude, the smallest things are logs. So ln, natural log, log base, whatever. Then comes powers, like polynomial, like x squared, x to the 3rd. Then comes exponentials. So that's the order. So for example, if you have the limit at x goes to infinity of e to the x over 4x to the 3rd, so the biggest degree thing, the biggest magnitude, right, is e to the x and 4x to the 3rd. But exponentials are just always going to be higher than powers. So the numerator is bigger, which means the limit does not exist. Over here, we've got a ln, a log here, but that's smaller. So the biggest degree thing would be 8x to the 73rd. And down here would be negative 7x to the, nope, I'm kidding. It would be also 8x to the 23rd. So 73rd. 8x to the 73rd. Since they're the same, the limit is 1. Because 8 divided by 8 is 1. All right, so just use this to help you figure out the order when logs and e to the x are involved. All right, go ahead and try the problems on Delta Math. I think that will help you clear up any misconceptions. They do a great job explaining, so even if you get the question right or wrong, look at the explanation, it's very clear. You can also email me or leave me a private message on the assignment in Google Classroom if there's anything you're still confused by or any other feedback about the lesson. Give it a shot. All right, great. See you live tomorrow.